you. So what we're starting today is Chapter 7. Chapter 7 is rational functions. So when we talk about rational functions, we're talking about fractional. So we're going to have variables in the numerator, denominator. We're going to be looking at fractions. And the first part that we're looking at is direct and inverse variation. Now, direct variation doesn't actually have fractions in it. One of the main forms of direct variation is y is equal to a times x, where a is a constant term. It's just a number. And it tells us the amount of change from one value to the next. Now, we could say that it's also x is equal to a times y. Both of these are similar. It's just another way to write it with our x and y. Or we can get the value of a by itself. So for our y equals a times x, if we divide both sides by x, we get a is equal to y over x. It's just another way to write it. Just a different version of the exact same equation. Or we can say a is equal to x over y. Direct variation. Now, one of the things that's interesting with direct variation is that they go in the same direction. As x increases, y will increase. As x decreases, y will decrease. They're either both going up or both going down. And our other variation is inverse variation. Y equals a over x. Or we could say x is equal to a over y. Normally we will just leave it as y equals a over x, but both of these do work. Then just like with direct variation, we can get the value of a by itself. And that's x times y. And this a value, this amount of change, will always be constant through a single function. So it'll be a single number. X and y will change, but a will always be a constant term. Now, inverse variation is a little bit different than direct. Inverse means that as one of the values increases, the other is decreasing. Or as one decreases, the other increases. Questions on this here? All right. Now, the first thing we're going to do is define direct variation, inverse variation, or neither, based off a function given. So the first one we have is this one here. X times y equals 5. We need to determine if it's direct, inverse, or neither. This first one would indeed be inverse. And there's a few ways we can get to it. One, well, x times y equals a is one of our forms, so it matches up with that there. The other is we can actually solve it. We could say x times y is equal to 5. And by solve, I mean just get y by itself, which would involve us dividing both sides by x, telling us y is equal to 5 over x. This is the standard form for inverse variation. So it is indeed inverse. We're going to skip over b for now, but let's look at c. Y over 2 equals x. Would we say direct, inverse, or neither? It is direct. Now, it seems a little odd that it is, because a way to make it look a little bit better is really this y over 2. Well, y over 2 is the same as 1/2 times y. So we have a times y equals x, and we get that form there. And again, another way we could get at just like the first one, y over 2 equals x. We can get y by itself. And to do that, we would multiply both sides by 2, telling us y is 2x. But really, if the variables are on opposite sides and in the top of the fractions and the numerators, it's going to be direct. If the variables are on opposite sides and one's in the top of the fraction and the other's in the bottom, it's going to be inverse. What do we think about B? It is neither. It is neither. Subtraction. Subtraction or addition. So negative is fine because you're talking about number 2. X times y equals 0.25. Negative 0.25. Now again, we could get y by itself by dividing both sides by x. Now we don't normally leave negative 0.25, a decimal, and a fraction together, but this is showing us that number 2 is actually what? Inverse.
Is number 1 direct?
Number 1 would be direct. And it's not so much the negative, but over here we have x times y is equal to a. It matches up with one of our forms of inverse. How about 3? Neither, neither. And that's because of our plus. Because if we look at all the different versions of direct and inverse variation that we have, it's all revolving around multiplication or division, or multiplying or dividing. Now, for the last 3 here, I'm going to write over the top of them, mainly because I ran out of room. I don't have any room next to them. But if we look at number A, or letter A for the first one, x times y equals 17, this would be this would be inverse. How about letter B? Neither, neither, because of the addition. So variables x and y are on opposite sides, yes? X equals a over y, yes? Y is in the bottom of the fraction. So it is direct, because x and y are both in the numerators. Does that make sense? Because here, really what we're saying also is that 1/10 times y is equal to, or we can multiply by 10 and say y is equal to 10x. Does that make sense? Yeah. If you're having trouble seeing what it is, try to get y by itself.
I was just saying, like, I was looking at x equals a over y.
So x equals a over y. The way that we would have that work would x is equal 4 over y. Y would have to be in the bottom. Does that make sense?
Yeah.
Questions on these here? I feel pretty good with identifying based off the equation. All right. Tell whether x and y are direct or inverse variation or neither based off the numbers given. Now again, with it being direct or inverse, we need a constant term, a constant amount for a given set of data. Now we do have several different versions of direct and inverse variation. But the ones I focus on, especially given a set of points, to determine if it's direct or inverse, are these here. Because our A amount should be constant. It should be the same for all the points that are given. So
it's like direct.
So direct, y is equal a times x. yes? So if I want to get a by itself, I would divide both sides by, so a is equal to y over x. Now, inverse y is equal to a over x. So to get a by itself, we need to multiply by x, because here the x and x would cancel, telling us a is equal to xy. So we solved it, giving us direct. It almost looks like a division. The original statement is actually multiplication. Since inverse's original statement is division, the variable a by itself is multiplication. It kind of makes sense? Yeah, so it's, how we get to there is not a whole lot important, but if a is direct, when we divide y over x, we should get the same amount every single time. If it's inverse, if I multiply x and y, we should get the same amount every time. So here, if we do direct first, y over x, I'm going to take every y value and divide it by its corresponding x and see what we get. So negative 12 over 2 is negative 6. Our next one would be what? Negative 6 over 4. And negative 6 over 4 is negative 3 halves or negative 1.5. So for the first two, did we get the same value for both of these here? No. So our a value for the first two, x and y, and the second two, x and y, are different, yes? With it being direct variation, that value has to be the same. That value of a should be constant throughout all of them. So we can say that this is not direct. So the next one we can do is inverse, or a equals x times y. Now the first one we can do is 2 times negative 12. Well, 2 times negative 12 is negative 24. Okay, let's move to the next one. 4 times negative 6 is negative 24. How about 6 times negative 4? Is negative 24. And lastly, 8 times negative 3. Did we get this same value of a for each and every one? So what can we say this is? Inverse. Because as soon as we get one value of a by doing direct or inverse that is not the same as the rest, we're done. Because they all have to be the same. Questions on A? Do we want to try direct or inverse variation for B? Direct. A equals y over x. So the first one we have is 2 over 1, which is 2. The next one we have is almost 4 over 2, which is 2, yes? They're both the same, so we can say direct, yes? Let's do the next one. What's the next one? 8 over.
Oh, yeah, it's not direct.
And if we went on and did the last one, 16 over 4. Because the first two are both 2, yes? Is our third one 2? Is the fourth one 2? It's very tempting to say yes, because after 2 it does work. But we do need to make sure to check. Right. So if we divided y over x and got the same number for all of them, then it would be direct. So let's try multiplying. So the first one's 2 times 1, which is 2. Next one is 4 times 2, which is. So direct did not work, inverse neither. So this is neither. On a side note, the actual equation for this is y equals 2 to the x. It's not really important because that's actually exponential. This is an exponential function. Because the next one, when x is 5, the y value would be 32. So it increases faster and faster as we go along. But questions on A and B? Number 4. Do we want to try direct or inverse first? Inverse. A equals x times y. So the first one we can do is 4 times 20. Negative 4 times 20 is? Negative 80. Negative 3 times 15 is?
Okay, let's try the
Negative 45.
Let's go on this one.
A equals y over x.
Is it y over x or x over y?
Either actually works.
Oh,
Because if we do x over y, 20 over negative 4 would be negative 5. Now if we did x over y, I'll do that over here. We would have negative 4 over 20, which is negative 1/5. It's just the reciprocal. Now if we went to the next one, 15 over negative 3 is negative 5.
I have a feeling, guys.
Over negative 3 over 15 would be negative 1/5. 10 over negative 2 is, and the last one, 5 over negative 1 is negative 5. If we continued on with the x over y, negative 2 over 10 is negative 1/5, and lastly, negative 1 over 5 is negative 1/5. So even if we did x over y instead of y over x, we still got the same term across all of them. It's just the reciprocal. Instead of getting negative 5, we got negative 1/5. So this is direct. Now, we didn't do this on the first two, but if we wanted to write this out, the equation itself, it'd be y equals negative 5x. Because we found the value of a is negative 5, we can plug it back in. Questions on number 4 before we look at number 5?
Hey, I have a question.
Yes.
It's not about math, but can you like, draw a capital versus like draw a right capital?
I can.
I'm struggling and I want to like.
I forgot.
Okay, never mind. I got it. Finally.
I got it.
Okay, yeah, I'm correct. I'm sorry.
You're good. Let's look at number 5. Do we want to try direct or inverse first?
Let's do it. Oh, sorry. Let's do direct. Don't follow me. Don't listen to me.
A equals y over x.
I've lost my expression.
So the first one is 60 over 1, which is 60. Our next one is
2 times 30.
30 over 2 is,
Oh, I'm fine. Sorry.
so direct gave us 60, then 15. So if we look at inverse, our first one is 1 times 60, which is 2 times 30 is our next one, which is 60. Our next one's 3 times 20, and 4 times 15 is, so this is inverse, because we got 60 on every single one when we multiplied the x and y values together. Questions on this here? Do we feel comfortable with these here? Okay. Are these here? The variables x and y vary inversely. So if it says that they vary inversely, what we're saying is y is equal to a over x. And y is equal to 4 when x is equal to 3. Write an equation that relates x and y, then find y when x is negative 2. So the first part of this is to actually find the equation. Find the value of y, not y, sorry. Find the value of a that will give us the actual equation to fill in. And they gave us an x and y here to actually find that out. So they told us x is 3 and y is 4. So we can fill that in from this here. So they're saying 4 is equal to a over 3. It is indeed. So the way we can find that is, well, we can multiply both sides by 3. These here will cancel, telling us a is 12. So the equation relating x and y is equal to 12 over x. So that's half the answer, and that will be, we'll need. Then find y when x is negative 2. So we take the equation, y, yeah, 12 over x, but our x in this case is, so y over negative 2, y is equal to negative 6. That's it. So we take the equation we found, y equals 12 over x, and it told us to find the value of y when x is negative 2. So we plug negative 2 in for x, simplify, and we're done. Questions on this here? On which part? Then find y when x is negative 2. Yeah, because it said, what's y when x is negative 2? So we plug negative 2 in for x. 12 over negative 2 is negative 6. Does that make sense? Okay. Need a second to write that down? Y equals a over x. So we need to find the value of a first, and then plug the value of x of negative 16 in to find y. So 8 is equal to a over 4, yes. Then we multiply both sides by 4.
And then it equals 32, right?
A is 32. So our equation, y is equal to 32 over x. So that is half of our answer. Y equals 32 over x, because we need to find the equation first. And that is, it actually does ask us to find the equation. Now to find the value of y when x is negative 16 would be doing exactly y over 32 over negative 16. And when we simplify, we get y is equal to negative 2. I am. So our two answers are y equals 32 over x and y is equal to negative 2. Questions on this here? Do we feel comfortable with this here? Yes. Is there one more of these that we want to do?
So are all those just going to be like the basic?
Yeah, I was going to say, let's do
So 8, y equals a over x. Now they tell us y is 16 when x is 1/2.
So it's going to be 8.
We're going to multiply both sides by 1/2. The 1/2 1/2 will cancel. And half of 16 is 8. Now we need to find the value of y when x is 2.
Four. I'm sorry, that took me forever.
Wait, where would we get the 2 from?
We got it from the equation. Then find y when x equals 2.
No, when x equals 2.
Yeah,
Oh,
that's
so-
the second part of the equation.
Oh,
So
Yeah.
after you
The big
basically
words?
solve all of
Yes.
that, how
Yeah.
do you get like y equals 8 over x? You have to use 2.
Yeah, so they, and especially on the homework, they will do that exact same thing. They're just going to give you a set value for all of them. And I believe the set value on the homework is 3. So if you get solving for y, you get a value of, say, 5/3. Leave it as 5/3. Don't rewrite it as 1.6 repeated.
Actually, I kind of need that more after that last test break.
It's scary. Is it?
Yes.
Oh, really? I want to say it was